Okay, so today we'll start our session with the discussion of Chomsky hierarchy of languages. So, what is this Chomsky hierarchy of languages? So, we came to know that we will be having four different types of languages, like type 3 language or type 2 language, next type 1 language, then type 0. So these are the four different types of languages are available, and depending on the type we will be having the corresponding language representation. If you are talking about type 3, it represents the regular language, and if you are having a regular language, then correspondingly we are able to generate the regular grammar for that regular language. And the automata which is responsible for accepting this regular language is the finite automata. So that is the reason why if you look into the table headings over here, so first we are looking into the what is the type of grammar it is. Then we are looking into what is the type of language it is going to generate, and what is the type of grammar it is going to support, and at the same time, so what is the type of automata so responsible for accepting the given type of language. Now we came to know that we already came to know that. So in our last two units, we have been discussing about the regular language and the corresponding automata which is responsible for accepting that regular language is the finite automata. So if you are having a regular language, now, so correspondingly for that regular language, we can easily generate the regular grammar also. So that grammar, we call it like a type 3 grammar. So please don't worry about the grammar and all these things. So we'll look into them later. So first of all, we try to understand this hierarchy. Okay. Then the second type of language is the which comes in our hierarchy is the context-free languages. So if you are having a context-free language, then the corresponding automata which accepts the context-free language is the push-down automata. And the grammar, so which will generate the context-free languages is the context-free grammar. And this context-free grammar also called like a type 2 grammar. Next comes the third type of language, which is the context sensitive language. So the automata used for accepting this context sensitive language is a linear bounded automata, and the correspondingly we are going to have a grammar called the context sensitive grammar. And this context sensitive grammar is also called like a type 1 grammar. Then finally, we have a recursively enumerable language. So the automata which is going to accept this recursively enumerable language is the Turing machine, and the grammar which it generates is the unrestricted grammar. So it is also called the type 0 grammar. Now, if you look into this diagram over here, so this is a type 3 language or type 3 grammar. On top of this type 3 grammar, we have a type 2 grammar. We have type 2 grammar or type 2 language. On top of it, we are having the type 1. On top of it, we have a type 0. So from this, we can say that, so this type 0 grammar is capable of having the all the, or it is going to act like a superset of all these languages. Okay, and this is the automata. Turing machine is the automata which is having the capability of recognizing the all types of languages. It is having the capability to recognize the recursively enumerable language, context sensitive language, context free language, and as well as the regular language also. The reason for that, because so this type 0 is going to act like a superset of all our languages, and corresponding we are having the corresponding automata. So hence this Turing machine is capable of recognizing all types of languages. Okay, then comes the subset of this one, which is a type 1. The corresponding automata which accepts this language is a linear bounded. See, you can see in your diagram also. So type 0 languages are accepted by Turing machine. Type 1 is accepted by linear bounded automata. Type 2 is accepted by push-down automata. And type 3 is accepted by the finite automata. So like this, we are having the correlation between the languages, grammars, and the corresponding automata which is responsible for accepting or recognizing those languages. Okay, now let's start and we'll look into what actually the grammar is. So technically any grammar, we are going to represent it with a capital G, and this grammar G will be consisting of four tuples. It will be having four tuples. So just like how we discussed our finite automata, and in our finite automata, we will be having five tuples like a Q, sigma, delta, Q naught, and F. Likewise, our grammar also will be consisting of five tuples. So, I mean, four tuples. So, what are the four tuples here? So, we have V. V represents set of variables, or we can also call them. Like non-terminals also. So V represents the variables or non-terminals. So usually the generic notation how we are going to represent the variables means, so all uppercase letters we call them like variables. All uppercase letters used are the variables. Then we have capital T. We have capital T, which is we call set of terminals. Set of terminals. So how do you identify the set of terminals means? So all lowercase letters. All lowercase letters we call them like terminals. Right? Then the third one which we'll be having P. P represents the set of productions. P represents the set of productions. And S represents the start symbol of the grammar. The start symbol of the grammar. Now, let us have a look at this. Let us try to understand this grammar with the help of one simple example. Now, if you look into this, now these are the what we call, all these are called the productions. We call them like productions. So what is the first production? P derives to epsilon in the sense. So it is possible that wherever we have a variable P, it is possible that that variable P can derive a epsilon. What is this derivation? We'll discuss later, but just try to understand the terminology first over here. Then the second production says that P derives to 0. P derives to 0. And the third production says that P derives to 1. And the fourth production says P derives to 0P0. And then fifth production says P derives to 1P1. So totally we are having the 5 productions. All these 5 productions are P productions only. Now, instead of making use of 5 individual productions, it is possible that we can go for writing them all those 5 productions with a single production itself. How? So let us observe. So we are going to write like this. P derives to epsilon, or P derives to 0, or P derives to 1, or P derives to 0P0, or P derives to 1P1. Okay, so now you can see over here, now from this production, these are all called the productions. So from these productions we can say that this P is capable of deriving epsilon, or P is capable of deriving 0, or P is capable of deriving 1, or it is capable of deriving 0P0, or it can be 1P1. So like this we are going to have the production rules or productions. We are going to have the productions. Now, once we have the grammar with this like this, so this is our grammar. This is our grammar. Now, once we have a grammar like this, so from this grammar, so first of all, we try to understand, so what are the variables? First of all, we try to get some idea like what are the variables and terminals. Then we can look into the deep into the details. Okay. So first we try to see what are the variables are. Variables means what? Variables means, so we are going to make use of all the uppercase variables. All the uppercase letters are variables. Now, if you look into this production, if you look into this, so what are the uppercase letters are there? We have only one uppercase letter, which is capital P. So hence this capital P is going to act like a variable. This is the only variable which is available in our productions. Okay, then the second one comes terminals. Terminals. So what are the various terminals are available? So the terminals are nothing but, you can see here, terminals are nothing but other than these uppercase letters, whatever you see on the right hand side of your productions, all those are terminals. So what are the various terminals we have? We have 0 and we have 1, and you can see here we have 0 0 1 1. When you write them inside the set, so set will not allow the repetition or duplicates. So hence we can write, so terminals are nothing but 0 comma 1. Then we have productions. P refers to what? Productions. So what are the productions are available? So these are nothing but the productions. What are the productions? First one is P derives to epsilon. The first production is P derives to epsilon. Then the second production is P derives to 0. P derives to 0. Then the third production is P derives to 1. Fourth production P derives to 0 P0, and the fifth production is P derives to 1 P1. So these are all nothing but the productions. We call them productions. All these productions has been represented inside a set. Okay. Then what is the start symbol of our grammar? What is the start symbol of our grammar? So start symbol is nothing but, so with which variable our grammar is starting with. So out of all these 5 productions, which one is the first production? So this is our first production. This is our first production. In our first production, so whatever the variable which is appearing on the left hand side in our first production, whatever the variable appearing on the left hand side of the production, it is going to act like the start symbol of the grammar. Okay, so this is how we are going to specify what are the various tuples of a given grammar. Okay, so just have a look at this. Just now we discussed, so grammar is nothing but it will be having 4 tuples. So variables, terminals, productions, and the start symbol of the grammar, right? So now as per our grammar example over here, for this grammar over here, we have identified what are the variables, what are the productions, and what are the terminals and the start symbol. Now let us take one more grammar. Let us see, let us take one more grammar, and we try to do the same for the second grammar also. Okay, so now we are going to specify E derives to E plus T or T. T derives to T star F or T star F or F. Then F derives to parenthesized E or ID. Parenthesized E or ID. Now this is our second grammar. Okay, so for this grammar, now we should write all these 4 things. We have to identify these 4 things. Let's go ahead and we try to write all these 4 things. So what is the first one? We have a variables. So variables means what? Just now we discussed that. Variables means all the uppercase letters which are available in our productions. Now if you look into these productions, so how many uppercase letters are there? We have capital E, that is the one variable. Then we have capital T, that is the second variable. And then we have capital F, which is the third variable. So totally how many variables are there? 3 variables are there. What are those? Capital E, capital T, and capital F. So these are the 3 different variables, so which are available in this grammar. Coming back to second one, which are the terminals? So terminals in the sense on the right hand side of your productions, please check on the right hand side of your production. Now you need to identify other than the variables. So if anything is existing in the sense, then that is what the terminal is. Now this is the first production, right hand side. On the right hand side, you have capital E, which is a variable. Capital T is also a variable. But the only thing which is remaining here is a plus. Now this plus is going to act like a terminal for us. That is the first one. Okay. Then second one. If you go for the second production, we have capital T, which is a variable. F is also a variable. But the only thing which is remaining here is a star. Now we can say that. So this star is also a terminal. Then go for the third production. In the case of third production, right hand side, so we have only capital E. Capital E is there. But on the left hand side of capital E, we have left parenthesis. On the right hand side of capital E, we have right parenthesis. So now this left parenthesis and the right parenthesis, they are also going to act like terminals. Okay, so left parenthesis and as well as right parenthesis, both are going to act like terminals. And what about this ID? This ID is a complete terminal. It is a single word. Okay, it is not individual. Like you cannot write or you cannot use a small I separately or small d separately. You are going to make use of that ID as a complete terminal. So totally, we can say that how many terminals are there in our grammar? So totally we have 5 terminals are there. What are those? Plus, star, left parenthesis, right parenthesis, and ID. Then coming back to productions, what are the productions we have? So totally we have various productions available. What are those? E derives to E plus T. That is the first production. Comma, comma. Just now I told you. So when I am having separated with the R symbol in the sense, then we can write, we can break them into 2 productions. So E derives to T. E derives to T. That is our 2 productions. As part of the first production, we got 2 productions. Then coming back to this one, we are going to get one again 2 more productions. What are the 2 more productions? T derives to T star F, comma T derives to F. Okay. Then last one. What is the last one? F derives to parenthesized E or ID. F derives to parenthesized E, comma F derives to ID. F derives to ID. So these are the 6 productions which comes as part of this grammar. Okay. Then what is the next one? S. S represents the start symbol of the grammar. Just now I told you, out of these 3 productions, which one is the first production? This is our first production. In that first production, what is the variable appearing on the left hand side of our production? Which is nothing but capital E. Now this capital E is going to become, or it is going to act like the start symbol of the grammar. Okay, so like this, what we are doing for the given grammar, we are able to identify what are the variables, what are the terminals, and what are the productions, and what are the start symbol of the grammar. Okay, so for your convenience, let us take one more example so that you should not get any doubt at all. Okay, so S derives to ASA or BSB or epsilon. S derives to ASA or BSB or epsilon. So this is my grammar. This is my grammar. For this grammar, now I need to identify what are the variables, capital V. So what are the variables are there? So if you look into this grammar, the only uppercase letter which is available is a capital S. So hence S is going to act like a variable. Then the second one is a terminal. What are the terminals? Just now I told you that. So anything which you see on the right hand side of your production, other than the variables. Now if you look into this production, so you have capital S which is a variable, but other than capital S, what you have? Small e. Now that small a is going to act like a terminal. And when you go for the second production BSB, we already know that S is a variable. Now we can say that B is a terminal. Okay. Then the third one is the productions. So what are the productions? We have three productions. Now straight away we are going to write them. So S derives to ASA, comma, S derives to BSB, comma, S derives to epsilon, Okay, so totally we got three productions, and then we need to identify what is the start symbol of our grammar. Now, what is the start symbol? We have only one production is available, so the start symbol will be S only. The start symbol will be S only. Okay, so this is how we are going to identify the variables, terminals, productions, and as well as the start symbol of the given grammar. Okay, so like this, so we are going to represent any grammar with the help of these four tuples. What are the four tuples? Variables, terminals, productions, and start symbol of the grammar. Now, what is the need? Why I am discussing about all these variables, terminals, productions, and all these things means the reason for that is now when I say something like this, when I give some grammar for you, for example, let us observe. If I give some grammar for you like this, now when I ask you, like, can you tell me what type of grammar it is? Whether it is a type 3 grammar, or whether it is a type 2 grammar, or whether it is a type 1 grammar, or it is a type 0 grammar. Now you have to tell me like what is a type grammar it is, which type of grammar it is. Now it is not possible for us, so straight away we can say, like, without having any knowledge, straight away we cannot say that. So this is going to be a type 1 grammar, or type 2 grammar, or type 3 grammar, or type 0 grammar. That is the reason why. So first we should know what type of grammars will be called like a type 0 grammar, and what type of grammars will be considered like type 1, and what is will be considered like type 2, and what will be the type 3 grammars. So for that we are having some rules and restrictions. Now let us go for the production rules. That is the reason why initially when I am discussing about the Chomsky hierarchy, I discussed about only these 4 points. I didn't discuss about these production rules. Now when you look into the production rules, see, depending on the type of the grammar what we are going to use, we are going to have the corresponding production rules. You can see here, for type 0 we have one set of production rules. For type 1 we have one set of production rules. For type 2 we have one set of production rules, and for type 3 we are having one set of production rules. Okay, now using these production rules, now we are going to decide whether it is a type 0 grammar, or type 3 type 1 grammar, or type 2 grammar, or a type 3 grammar. Now we are going to write some example productions. We are going to write some example productions so that it becomes very clear for us that just by looking at the grammar productions itself, you people might be in a position to identify what type of grammar it is. Okay, now first of all we'll start with the very simple one. Please try to understand. We'll try to explain with the very simple one, which is the type 3 grammar, which is the regular grammar. Type 3 means regular grammar. Now let us say what type of grammar will be considered like a type 3 grammar or regular grammar. Means if the grammar productions are in this form. What is that form? Capital A derives to small a capital X, or small a, or capital A derives to capital X small a, or small a. If the grammar productions are in this form, either of these two forms, now we can say that such type of grammar is the regular grammar. Okay, now here you should know what this capital A is. Just now I told you all the capital letters, if you are representing in the sense, capital letters will be belonging to what? This capital A and capital X will be the set of variables. Capital E and capital X should belong to the variables. And what about this small a? This small a will belong to the set of terminals. Just now in our previous discussion, we discussed that variables is nothing but set of variables will be, we are going to represent in the uppercase letters, and the terminals we are representing in the lowercase letters. Now as per that, see here we have one uppercase letter capital A and the other uppercase letter capital X. Hence these two are going to belong to the variables. And we have only one lowercase letter which is a small a. So we call them like terminals. Okay. Now I am going to write one simple example for this regular grammar. S derives to 0, 0, S, 0S or 1. 0S or 1. Now you can see here, is this production is available in this form or not? What is that form? So first on the left hand side of a production, you should have a variable. Yes, we have a variable. Then immediately on the right hand side, first it should start with a terminal. Do we have a terminal or not? You can see here 0 is a terminal or not? Yes, it is a terminal. And then immediately followed by that terminal, we should have a variable. Do we have a variable or not? Yes, we have a variable. Then immediately or again you can have a terminal. Now we have a terminal or not? Yes, we have a terminal. Now we can say that this is going to be a regular grammar, or I can write in other way also. What is that? S0 or 0 or 1, whatever it may be. S0 or 1. You can see here. Now as per this second production, you can see here as per this second production, first on the left hand side we should have a variable. Yes, we have a variable like this. Then on the right hand side of my production, it should begin with the variable. Yes, it has begun with the variable. Then immediately followed by that, we need to have a terminal. Yes, we are having a terminal. Then followed by that, your variable will be associated with one more production which should produce only one terminal. Yes, it is producing only one terminal. Okay. Now I can say that. So this is what we call an example for the regular grammar. Now, when you look into this regular grammar is again divided into two types. So please keep it in mind and please try to make a note of it. So this regular grammar has been again divided into two types. What are the two types? The first one is the right linear grammar and the second one is the left linear grammar. So I already make a note of it. So the first one is called the right linear grammar and as well as the left linear grammar. Now out of these two, so which one is the left linear grammar and which one is the right linear grammar? See, let me tell you, both of them are regular grammars only. Both of them are regular grammars only. But more specifically, one out of these two, one is a regular right linear grammar and second one is a left linear grammar. So what is a right linear grammar or left linear grammar? In the sense, first go to the right hand side of the production. Go to the right hand side of the production. In the right hand side of the production, check where the variable is appearing. So if you see in my first production, the variable S is appearing on the right hand side of a terminal. Yes or no? So this is a terminal and to the right hand side of the terminal, the variable is appearing. So hence we say that this is going to be the right linear grammar. This is going to be the right linear grammar. Then if you look into the second production, so first we have a variable followed by the terminal. We have a variable followed by the terminal. So as we have a variable first followed by the terminal, hence it is called the left linear grammar. Left linear grammar. Or in some other way I can tell you, so check where the variable is appearing. So if the variable is appearing to the right hand side of the terminal, then it is called the right linear grammar. If the variable is appearing to the left hand side of a terminal, now we can say that it is the left linear grammar. Okay. But you should remember that if I want to say some grammar like a regular grammar, must and should, that grammar must satisfy these two rules. These two rules. If these two rules are satisfied, then only we can say that that grammar is a regular grammar. Okay. Now let us come over here. Just check whether we have such type of examples for regular grammar or not. Now, if you observe, this P belongs to epsilon, it is not a regular grammar. Why? Because in our productions, so nowhere we got the discussion about the epsilon. Okay, so that is the reason why it is not a regular grammar. Then what about this P derives to 0? Can we consider it like a regular grammar? Why? Because you can see here, what is the productions we have? S derives to 0s or 1. Can we write like s derives to 0s and s derives to 1? Can we write like this or not? Yes. Now we can say that this grammar can be considered like a regular grammar. Regular grammar. And what about this one? What about this one? This is also going to be a regular grammar. Then what about the fourth one? P derives to 0p0. So is it available in our form? What is our form? A derives to either small a, capital A, or it should be capital A or a small a. It should be like this form only. In the sense, we need to have one terminal followed by one variable, or one variable followed by one terminal. This should be in this form. Then only we can call it like a regular grammar. But what is the form it is available in? We have a terminal followed by a variable. That's fine. But apart from that, we also have followed by this 0, which is a terminal. Now, is it following this rule? Is it following this rule or violating this rule? It is violating this rule. So hence we can say that this production and these two productions are not regular grammars. Okay, fine. Now let's go over here. Now if you look into this, all these grammars are not regular grammars. So if you take this, so E derives to E plus T, it is not a regular. T derives to T, it is also not regular. T derives to T star F, it is not regular. T derives to F, it is also not regular. Then F derives to this one, it is also not regular. But you can take F derives to ID, which is a regular grammar. Why? Because you have a production like A derives to a terminal symbol. A derives to terminal symbol. Now you can see here, F is deriving a terminal symbol. Now we can say that. So this is the only grammar which is going to be a regular grammar as per our second productions. Second grammar. Now if you go for the third grammar, as per the third grammar, none of these productions are available in the regular grammar format. You can see here, so nothing is there. Nothing is available as per our required form. Hence we can say that, so all these are not following the type 3 rules. Type 3 grammar rules. So hence we can say that they are not regular grammars. Okay, then go for next one, which is a type 2 grammar, also called the context free grammar. And always these type 2 grammars are available in this form. What is that form? A derives to alpha. A derives to alpha. So where, what is this A refers to? You know already. A refers to what? The set of variables. A refers to variables. Okay. And alpha belongs to what? Please observe. Alpha belongs to variables or terminals or the combinations of variables and terminals whole power star. When I am going to make use of star, what do you mean by that? It means that this alpha can be epsilon also. Please remember that when I use star over here, this alpha can be epsilon also. Okay, and or it can be, you can have this alpha can be, please try to understand what this alpha can be. This alpha can be either epsilon, or this alpha can be having only variables, or this alpha can be having only terminals, or this alpha can be having the variables and terminals also, both variables and terminals also. Okay, let us write a few examples for this. So first I will try to write s derives to 0 s 0, s derives to 0 s 0. Now please observe, now 0 is a terminal and s is a variable. Now we have a combinations of variables and terminals or not? Yes. As we have a combination of variables and terminals, now we can say that it is the context free grammar, or it is the type 2 grammar, or this can have, your grammar can have only variables. Only variables. What are the variables? Something like this. Now please observe, s derives to double s. Only variables are there. So is it a context free grammar? Yes, it is a context free grammar. How we are saying it is a context free grammar? You can see this. We have written a derives to alpha, where alpha belongs to what? The combination of variables or terminals or both. Now you have a combination of variables. As you have a combination of variables, now we can say that it is a context free grammar. Then you can have also like this, s derives to 4 zeros. What is these 4 zeros? These 4 zeros are nothing but the combination of only terminals. The combination of only terminals. Now we have the first one, the combination of variables and terminals, the combination of only variables, the combination of only terminals. Not only this, you can also have s derives to epsilon also. S derives to epsilon also. Now this is also the type 2 production. This is also the type 2 production. Okay. If your productions are available in this type 2 form, now we can say that such type of grammar is the context free grammar. Now if you look into this example, now I can say that p derives to epsilon. Is it a type 2 grammar or not? Yes, as it is a type 2 grammar, now I am going to write, in order to make you clear, this is a type 2. And what about this one? P derives to 0. Now, is it available something like it is consisting of only terminal or not? Yes, as it is having only terminal. Now I can write it is also a type 2 grammar. Then what about this one? As we have only terminal, it is also a type 2 grammar. But here, please observe, we have terminal followed by variable followed by terminal. In the sense, we have a combination of both variables and terminals. So hence, it is also the type 2 grammar. It is also the type 2 grammar. Okay. Then last one, variables and terminals combination. Yes, it is also a type 2 grammar. But what about this one here? If you look into this one, so if you look into this one, this entire productions or this entire grammar is a best example for the type 2 grammar. Why? Because you have a combinations of variables and terminals, and you have only variable, combination of variables and terminals, only variable, combination of variables and terminals, and terminal, only terminal. Now this entire grammar will be the best example for the type 2 grammar. And here also, this is also a type 2 grammar. Why? Because we have epsilon and we have combinations of variables and terminals. And here also we have combinations of variables and terminals. Now that is the reason why we can take like this entire grammar is a type 2 grammar. This entire grammar is also a type 2 grammar. And here also, whatever the productions we have taken, so this entire grammar is also a type 2 grammar. But here, this one is a best example for both. This grammar will be consisting of few productions which are belonging to type 2 and which are belonging to type 1 also. No problem. I mean type 3 also. No problem. Why? Because our type 2 is a superset of what? Type 3. Okay, where type 3 is a subset of type 2. That is the reason why it is possible that you may get in type 2, you may get some of the productions which will be of type 3 productions. Okay, so like this, if you are having some productions like this is how you are able to identify whether it is a type 3 production or type 2 production. Okay, then go for next one, which is a type 1 grammar. So type 1 grammar is also called a context sensitive grammar. So always this type 1 productions will be available in this form, something like alpha derives to beta, alpha derives to beta. And you know, already you know that what is this alpha and beta is. So this alpha and beta will be representing the combination of variables and terminals. Alpha and beta represents the combinations of variables and terminals. Now please remember that there is one very two important rules are there. So these are the two important rules. This is the first one and this is the second one. The first one says that always the length of the alpha part should be less than or equal to the beta part. Now, when we write something like this, always remember that the left hand side length should be less than or equal to the right hand side length. Then only it will be considered like a context sensitive grammar. Then the next very important rule is, so epsilon is allowed only, please observe, go for the second rule. The rule s derives to epsilon is allowed if s does not appear on the right hand side of any rule. In the sense, it says that, so whatever the grammar you take as part of your type 1, you should be make sure that epsilon should not appear on the right hand side of any production. Okay, now let us write one small example for this type 1 grammar. So just now I told you what this alpha means. Alpha is a combination of variables and terminals, and beta is also combination of variables and terminals. Now I am writing, so small a capital S derives to small b capital B small a capital A. Now this is one example for the production which is the type 1 grammar. Why it is called like a type 1 grammar? Because on the left hand side we have a combinations of variables and terminals, and on the right hand side also we have the combinations of variables and terminals. And one more thing here, so if I want to call this production like a type 1 production, we need to make sure that the length of the left hand side part, should be less than or equal to the length of the right hand side part. So what is the length of the left hand side part? 3. And what is the length of right hand side part? 4. And nowhere we have the epsilon production available. Nowhere we have the epsilon production available on the right hand side. Now I can say that this is going to be a type 1 production. Okay, and then let me write one more production. A capital S A capital S A, then I have small a. Now please observe, can we call this production like a type 1 production? So this is not going to be a type 1 production. Why it is not a type 1 production? The reason for that is, yes, we have a combination of variables and terminals on the left hand side, and we have only combination of terminals on the right hand side. This one is okay. But when you consider the length of the left hand side part, the length of the left hand side part is 3 and the length of the right hand side part is 2, where 3 is less than or equal to 2. The condition is false. So this is not going to be the context sensitive grammar. Okay. Now let me write one production which will satisfy this rule. Okay. Now let us take one small example. So s derives to 0 0 s 0 0 s 0 r 1 s 1. This is a one production, and then we have a derives to epsilon. Now I can say that this grammar is a context sensitive grammar. This grammar, whatever I have written over here, this grammar is a context sensitive grammar. How it is a context sensitive grammar? Just have a look at this. So this will be, let me divide like this. Just have a look at this. On the left hand side, just now I told you that we will be having a combination of variables and terminals. And now we have only a variable, but here we have variables and terminals combination. That's fine. Now let us check the length. Length is 1, length is 3. 1 is less than or equal to 3. The condition is true. and we don't have any epsilon productions also. So we don't have any problem. Same with the case of second one also. But what about third one? Now when you look into the third one, we have a variable and it is deriving epsilon. Now as it is deriving epsilon, now we can say that it is also part of a type 1 grammar. Why it is part of a type 1 grammar means, because please remember that, so this a is there now, this variable capital A is not appearing anywhere on the right hand side of any productions. That is the reason why you can consider it like this is going to be a type 1 productions or type 1 grammar. Now let me write one more example over here. So this is the first example. This is our first example, which is the, yes, it is the context sensitive grammar. So second one is not the context sensitive grammar. So the second one, so this one is not the context sensitive grammar, and this one is also the context sensitive grammar. But what about the fourth one? Now I'm going to write the fourth one. S derives to 0, S0, and then S derives to epsilon. S derives to epsilon. Now have a look at this. S derives to epsilon. Now when you go for this fourth prediction, now the first one says that first prediction of the fourth grammar says that the S derives to 0 is 0. So we have a first rule satisfied, no problem. Then what about the second rule? The second rule says that whenever you have some production, epsilon production, you need to make sure that this variable which is producing the epsilon should not appear on the right hand side of any production. Now what is happening over here? So what is the variable producing the epsilon over here? Capital S is producing the epsilon over here. Now we need to make sure that this epsilon, this capital S, which is deriving the epsilon production, so should not appear on the right hand side of any of our production. But unfortunately, what happened over here? If we have a production called S derives to 0 S0, where the S is appearing on the right hand side of the production. So hence we can say that, so this is not going to be the context sensitive grammar. But when you go for the third production, have a look at this third production. We can say that why it is a context sensitive one. Why it is a context sensitive one? The reason for that is, what is the variable which is producing the epsilon over here? Capital A. Capital A. And apart from this, we have two other productions. Now just check the other two productions right hand side. So check the right hand side of the first production. Check the right hand side of the second production also. So nowhere on the right hand side of any production this capital A is appearing. As capital A is not appearing on any production on the right hand side of any production, so hence we can say that this grammar is the context sensitive grammar. Okay, so please try to remember that whenever we want to use any epsilon production in the context sensitive grammar, we need to make sure that the variable which is producing the epsilon production should not appear on the right hand side of any other productions. If it is happening, then we can call it like a context sensitive grammar. But in the fourth case, what is happening over here? In our fourth case, the thing is the completely diverting. So what is the rule over here? So it should not appear on the right hand side. But what is happening over here? So S is deriving epsilon, but that epsilon is appearing on the right hand side of the production. So hence we can say that, so this is not going to be the context sensitive grammar, and this is also not going to be the context sensitive grammar. Okay, so this is what we call the type 1 grammar is. But what about last one? So fourth one is so type 0 grammar. We don't have any restrictions at all. We need to make sure that on the left hand side, so any production which is of this form, like alpha derives to beta, is called the type 0 grammar. but you need to make sure that on the left hand side at least one variable must be there. Please observe over here what is happening here. Alpha belongs to what? Variable or terminals whole star followed by a variable, or variable or terminal whole star. In the sense, you need to make sure that at least one terminal must be available on the left hand side of the prediction. And when you come for the beta part, this beta part can be either epsilon, or it can be a variable, or it can be a terminal, or it can be combinations of variables and terminals. Now please observe over here. So whatever the predictions which I have written over here, all these predictions are best examples for a type 0, because in this type 0 we have a flexibility of making use of epsilon also. And here also whatever we have written for type 2 grammars, all these are best examples for type 0, and this is also best example for type 0. That is the reason why, so we say that type 0 is a superset of all other types of grammars. And this Turing machine is having the capability to recognize all types of languages, all types of languages. Okay, so the best simple example, now here I am not going to write any predictions at all, because whatever the predictions which you are written so far, all these are best examples for the type 0 grammars. Okay, so with this we have come to the end of today's session, where we have discussed about the Chomsky hierarchy of the languages, and then we have discussed about the different types of grammars, and we have given some introduction and some examples also related to the context-free grammars also. So with this, I'm going to conclude my session. Thank you very much for joining the today's session.